Hello learners, it's me again G2 and welcome back to G2's News. By the way learners, if you're new to this channel, please consider subscribing and like this video, and also don't forget to hit the notification bell for my upcoming videos. In this video, we will learn finding the LCM using continuous division or the ladder method. To define the LCM or least common multiple, it is the smallest number that is multiple of two or more numbers. To help us understand better the definition, let us have this example. We have the number 2 and we will get its multiples. To do that, we will multiply 2 with any number, and the number that we get is a multiple of 2. For example, 2 times 1 equals 2. 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. And so on. We cannot write all the multiples of 2 because multiples are infinite or endless. Again, these are the multiples of 2. Let's have 4. We will multiply 4 with any number to get its multiples. Like 4 times 1 equals 4. 4 times 2 equals 8. 4 times 3 equals 12. 4 times 4 equals 6. 16. And so on. Again, we cannot write all the multiples of 4 because the multiples of a number are infinite and endless. Again, these numbers are called multiples of 4. 2 and 4 have common multiples. Common means the same. Their common multiples are 4, 8, and so on. We still have many common multiples if we continue multiplying 2 and 4 with any number.
Why do we need to learn the skill of finding LCM? LCM helps us find the LCD of fractions. We can also use it in solving math problems that we may encounter in our daily lives. In finding the LCM using continuous division, remember, using a common prime number to divide at least two of the numbers without a remainder. And since we will be using prime numbers, so take note of these 5 prime numbers because they are commonly used in this method. 2, 3, 5, 7, and 11. We can still use the other prime numbers. But 2, 3, 5, 7, and 11 are always used, so better to remember them. Let's begin with our first example. Find the LCM of 6 and 8. First, let's make an L shape, then arrange the given numbers 6 and 8 horizontally. Then what prime number can divide at least 2 of the numbers? Remember, we can continue if at least 2 of the numbers can be divided by a common prime number. Let's see from these prime numbers if any of them can divide both 6 and 8. So 2 can divide both 6 and 8 without a remainder. So let's write 2 on the side. Then let's make another L shape for the answers. Now let's proceed for division. 6 divided by 2 equals 3. Then 8 divided by 2 is 4. Now the remaining numbers are 3 and 4. What prime number can divide at least 2 of the numbers? Let's see from this prime number if any of them can divide both 3 and 4. No prime number can divide both 3 and 4. So, this means we will now stop dividing. Next to do is to take the number on the side and as well as the numbers below, and we will multiply them. 2 times 3 times 4 equals 24. So the LCM of 6 and 8 is 24. Yay! So now let us get the LCM of 3 numbers. Let's answer these. Find the LCM of 4, 12, and 18. First, let's make an L shape and then put the given numbers 4, 12, and 18 on the horizontal line. What prime number can divide at least two of the numbers? Remember, we can only proceed with the process only if at least two of the numbers can be divided by a common prime number without a remainder. Although we have three numbers here, but we only need at least two of them to have a common prime factor to continue. Let's see from these prime numbers if any of them can divide at least 2 of 4, 12, and 18. Okay, so 2 can divide exactly for 4, 12, and 18. We can also take 3 because it can divide 2 of the numbers like 12 and 18. So we can choose either 2 or 3 as our divisor. Let's choose 2 but don't get confused because we can also use 3. Either of them can still lead us to the correct answer. Let's make another L shape for the answers. Now let's proceed for division. 4 divided by 2 equals 2. 12 divided by 2 is equals to 6. 18 divided by 2 is 9. So now the remaining numbers are 2, 6, and 9. Then what prime number can divide at least two of the numbers? Remember again, we can only go on with the process only if at least two of the numbers can be divided exactly or without a remainder by a common prime number. So, let's see from these prime numbers if any of them can divide at least 2 of 2, 6, and 9. Okay, so 2 can divide exactly both 2 and 6. Then 3 can divide both 6 and 9 without a remainder. So we can use either 2 or 3. Let's try using 3. Okay, let's put 3 here. Then let's pick another L shape for the answers. And now let's proceed to division. Let's just copy 2 because it can't be divided exactly by 3 without remainder. Then 6 divided by 3 equals 2. 9 divided by 3 equals 3. And now the remaining numbers here are 2, 2, and 3. So what prime number can divide at least 2 of the numbers? Remember again, we can only continue with the process only if at least 2 of the numbers can be divided exactly or without a remainder by a common prime number. So, let's see from these prime numbers again if any of them can divide at least 2 of 2, 2, and 3. So 2 can divide at least 2 of the numbers like 2 and 2. So let's put 2 here and let's make another L shape for the answers. And now let's proceed to division. Let's just copy 3 because it cannot be divided exactly by 2 without a remainder. Then 2 divided by 2 equals 1. Then 2 divided by 2 equals 1. And now our remaining numbers are 1, 1, and 3. Then what prime number can divide at least 2 of the numbers? Let's see from these prime numbers if any of them can divide at least 2 of 1, 1, and 3. No. We don't have any prime number that can divide exactly 1, 1, and 3. So, this means we will now stop dividing. Next to do is to take the numbers on the side, and as well as the numbers below, and we will multiply them. 2 times 3 equals 6. 6 times 2 equals 12. 12 times 1 equals 12. 12 times 1 is 12 again. Then, 12 times 3 is 36. So, the LCM of 4, 12, and 18 is 36. So, always remember in finding the LCM using continuous division, remember, use a common prime factor to divide at least two of the numbers without a remainder. If you find this video helpful, please don't forget to give it a thumbs up. Bye learners! See you on my next video!